All right, let's dive into a cosmic cold case. We're talking about a true detective story, but this one's about a star that gets way too close to its partner and ends up getting eaten alive. Our suspect? A celestial cannibal that goes by the name M71A.
Okay, so before we even get to the crime scene, we've got to profile our suspect. It's called a Black Widow pulsar, and yeah, that name is terrifyingly accurate. So what you're looking at is the corpse of a massive star that went supernova. It's this tiny, incredibly dense thing called a neutron star. But this is no quiet corpse. Oh no, it spins hundreds of times a second, blasting out these intense beams of radiation, kind of like a crazed lighthouse. And it uses all that energy to literally sandblast its partner star completely out of existence.
So the big question is, how is a monster like this even made? Let's dig into the origin story of our cosmic cannibal.
You know, there's a really tragic twist to how these things form. It all starts with a pair of stars. The living star, it gets old, it swells up, and its material gets siphoned off by its dead partner. But this act of giving, well, that's what creates the monster. All that stolen material spins the dead star up to these insane speeds, turning it into what we call a millisecond pulsar. And then, in the cruelest twist of all, the pulsar uses its new power to vaporize the very star that gave it life in the first place.
Now, our suspect isn't the only killer out there. It actually belongs to a whole family of them. M71A is a Black Widow, which means its companion is super tiny, less than a tenth the mass of our Sun. Its cousins are called redbacks, and their victims are a little bit bigger. But really, it all comes down to the size of the victim. That's how astronomers classify these incredibly violent relationships.
All right, let's head to the crime scene. It's a place called a globular cluster. Its name is M71. I want you to picture a super dense, ancient city just packed with over 1 million stars. It's crowded, it's chaotic, and it's the perfect place for a cosmic crime to go totally unnoticed.
The challenge for astronomers here was just immense. I mean, somewhere in this glittering metropolis, they had to find one specific system, a hyperactive stellar corpse and its incredibly faint, dying companion. Talk about a needle in a haystack, right? Where do you even begin looking?
Well, the first big break in the case didn't come from a picture. It actually came from sound. Astronomers used these really powerful radio telescopes to just scan the cluster, listening for that telltale pulse of a rapidly spinning neutron star. And boom, they found it, a signal pulsing at just an unbelievable speed. This number, 204.57, that's how many times our suspect spins every single second. It completes over 200 rotations in the time it takes you to snap your fingers. That was it. That confirmed they had a millisecond pulsar on their hands.
But that radio signal also gave them another critical clue. It was wobbling, just a tiny bit. And that meant the pulsar wasn't alone. Its partner was whipping around it at an incredible speed, completing a full orbit in just 4.2 hours. I mean, that revealed just how terrifyingly close they were, locked in a true death spiral.
Okay, so they had a precise location and they had a motive. The detectives knew where the pulsar was and that it was destroying a companion. The final step was to get visual confirmation, to actually see the victim. And for that, they turned to the big guns, the Hubble Space Telescope.
This was really the moment of truth. All the data pointed to this tiny, faint star just being roasted by the pulsar. But seeing it, that's a whole other thing. Would it even be bright enough for Hubble to spot, especially against the backdrop of 1 million other stars? They found it, and they caught it right in the act. When the side of the companion star getting blasted by the pulsar faced us, Hubble saw this tiny little speck of light. But then, as the star continued its 4.2-hour orbit, its cooler night side turned toward us, and it vanished completely. This flickering, perfectly in time with the orbit, that was the smoking gun. As the research team themselves put it, this established the physical connection. Basically, the rhythmic blinking proved that the faint star wasn't just some random object. It was physically tied to the pulsar. They had found their victim. The case was officially confirmed.
So, mystery solved. But what does this one cosmic crime scene actually teach us about the rest of the universe? Why does it matter? First off, the sheer violence of this relationship is just staggering. The side of the companion that's facing the pulsar is heated so intensely that it becomes over 20 times brighter than its dark side. This isn't just a gentle warming, it is a constant, brutal roasting that causes this extreme change in brightness.
Look, this discovery is actually a huge deal.
It's only the second black widow companion ever found in one of these dense star cities, and it looks almost identical to the first one. That suggests there's a common way these things evolve. But more importantly, it helps fill in this crucial gap in our understanding. See, astronomers have this theory that these black widow systems are the missing link between bright, chaotic X-ray binaries and all the lonely, isolated millisecond pulsars they see. This could be that final, violent stage where the pulsar destroys the companion that created it, effectively erasing all the evidence of its own birth.
And you know, that just leaves us with one final, kind of haunting question. This discovery solves one mystery, but it opens up a whole new one. What happens when the black widow is finished? Once it has completely consumed its partner, will it just be a solitary pulsar, spinning alone in the dark, with all evidence of its cosmic crime completely erased forever? Well, that is a mystery for the next generation of cosmic detectives to solve.